Measuring the true performance of wide bandwidth radar transmitters. Modern radar systems require more processing gain to improve range resolution, which in turn drives wider modulation bandwidths. Radar systems also employ complex pulse modulation to improve range resolution and lower the probability of intercept and susceptibility to jamming. Many systems also operate at higher frequencies up to Ka band, which helps to support the wider modulation bandwidths, increased capacity, and smaller antennas. Measuring the performance of radar transmitters in an accurate and cost-effective manner offers many challenges. It is difficult to measure high-frequency and wide bandwidth transmitter outputs directly, and when downconverter hardware is used, it adds its own impairments into the test signal. In this video, we show how radar transmitter outputs can be measured directly up to 32 GHz without the use of external downconverter hardware. This radar pulse measurement setup shows how wide bandwidth radar signals can be created and analyzed. First, we start with Waveform Creation software, such as Agilent System View, or in this case, MATLAB running on the Infinium 90000X series oscilloscope, which is used to create and download the radar waveform to the 81180A wideband arbitrary waveform generator. The differential IQ signals are modulated by the E8267D PSG vector signal generator to output an X, Ku, or Ka band signal. This test signal would be input to a device under test. However, in this case, we are inputting directly to the 90000X series oscilloscope. This oscilloscope with the 89600A VSA software enables a wideband radar test signal to be analyzed directly at X, Ku, and Ka bands up to 32 GHz without the need for external downconversion. Now let's zoom into the 90000X series oscilloscope's desktop, where we'll use MATLAB to create the radar IQ waveform. The radar pulse utility is used to create the 2 GHz wide LFM chirp waveform. You can see the pulse repetition interval is set to 50 microseconds, pulse width is set to 1 microsecond, and frequency span is set to 2 GHz. We apply amplitude corrections and press download to generate the X-band 2 GHz LFM chirp test signal with the 81180A AWG and the E8267D PSG. The oscilloscope software application shows the pulsed radar waveform from the PSG. Let's use a custom MATLAB function to perform envelope measurements on the waveform. To do this, we select Analyze, Math from the pull-down menu. The operator is set to the MATLAB user-defined envelope function. Select the Display on checkbox to view the MATLAB applied trace. After closing the dialog box, we now see a yellow trace outlining the LFM chirp radar pulse. This is the resulting RF envelope magnitude. The Agilent 90000X series oscilloscope can also be used with your MATLAB user-defined functions to perform custom or proprietary measurements. Now let's perform some measurements on this pulsed RF envelope. To measure rise time, fall time, and pulse width, we simply drag and drop pre-configured measurements onto the pulsed RF envelope. First, there's rise time with the measurement results below. Next, fall time. And lastly, there's pulse width. For pulse width, we select the More button and then click on the pulse width icon. A number of other measurements can be performed by dragging and dropping additional measurements in a similar manner. You've just seen some examples of time domain measurements. It's often useful to view frequency domain characteristics of radar signals as well. This can be done with the combination of the VSA software and the wide bandwidth capabilities of the 90000X series oscilloscope. Let's recall a VSA measurement setup configuration. We can see the 2 GHz wide radar spectrum centered at 12 GHz. The log magnitude envelope versus time is shown below. The chirped phase is shown on the upper right and the 2 GHz wide LFM chirp on the lower right. Many other measurements can be performed with the VSA software, such as viewing frequency hopped characteristics or demodulating various signal formats for wideband communications. We have just shown how the 90000X series oscilloscope can perform wideband radar transmitter measurements directly up to 32 GHz without the need for external downconversion hardware, which can introduce their own impairments into the test signal. Measure the true performance of your wide bandwidth radar transmitter. For more information, please contact your local Agilent Technologies representative or visit us on the web. Agilent.com/find/oscilloscopes, Agilent.com/find/AWG, or Agilent.com/find/AD.